What is the expected splitting pattern for the HNMR peak of the hydrogen on the carbon pointed to in the molecule shown below? So we're talking about this carbon right here, which has an H right here. Now, number of hydrogens on this carbon in particular does not matter. It's just going to influence the height of the peak, but we're not talking about that. We're talking about splitting pattern. So let's take a look. I'm going to draw some common peaks that we have in HNMR spectra. So right here, look at this, right? It goes like this, right? This is a singlet. This one goes up and like that. This is a doublet. This one goes like this. You can see the pattern. It's called triplet. This is called a quartet. And this is called a quintet because it has like 5 of those little peak things, right? Anything above this is going to be called a multiplet. Some people consider 5 in-on multiplets. I consider 6 in-on multiplet, but it doesn't really matter. So how do we get this? The formula I use is like number of splitting, right? Equals n plus 1. What is n? N is the number of hydrogens on the adjacent carbons, okay? Overall hydrogens. So let's take a look at this, okay? Right here, we have one adjacent carbon here, adjacent carbon, and adjacent carbon, right? Because we're looking at this carbon in particular. So we have these 3. Now, looking at this carbon, how many hydrogens does it have? This has no hydrogens because it has all 4 bonds already fulfilled. Now looking at this one, this has 3 bonds fulfilled, so it has 1 H. This one only has 1 bond fulfilled, so it has 3 H's, okay? So how many adjacent carbon hydrogens are there in total? There's 4, okay? So that means we're going to have 4 plus 1, which is 5, which is quintet, which is answer choice D.